Hello all, welcome to the show. I'm Gus Gagliardi and this is Firecode Tech. On Firecode Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Firecode Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. It's episode 3 of Firecode Tech. Today we have David Stacy. Dave is a licensed fire protection engineer with formal education in fire protection engineering from the University of Maryland. Dave has a unique perspective on engineering design and fire protection for the built environment because he has experience as a firefighter and has actually had the hands-on experience of being at structure fires and live firefighting. One of the reasons why I was interested in talking with Dave is he specializes in performance-based design and has his own consulting practice. In episode 3 of Firecode Tech, we expand on the differences between prescriptive design and performance-based design, and Dave takes us through the process of performance-based design from start to finish. We had a little bit of trouble with Dave's audio, but I hope you'll stick through the whole interview because Dave has a lot of great takeaways. Don't forget to follow us on social media and subscribe to Firecode Tech so you never miss an episode. Let's dive in. Well, welcome, Dave. Hey, thanks for coming on the podcast.
Yeah, no problem. Thanks for having me today.
Can I get a little bit about your background and how you got into fire protection?
Yeah, so I've been in the fire protection engineering field specifically for about 10 years. And really, my overall background has mainly been based around the fire service. So growing up, I was always interested, becoming a firefighter. I had family members that were in the fire service, and that was really, what I saw myself doing in life. And I continued that. I joined the local volunteer department when I was in high school, got into the fire service side of it, and then of course through college went on and got my education in fire protection engineering, and went into that road as well. So overall, my background in the fire protection field is kind of both sides, both the operations and suppression side, active in the fire department, as well as the background on the engineering and life safety side as an engineer.
So you said that you grew up knowing people who were firefighters and that's something that interested you from an early age, or you were just exposed to that very young?
Yeah, absolutely. My father in particular, he retired as a captain from the city of New Haven, Connecticut Fire Department, and that's where I grew up and really got started with my career in the Connecticut area. So yeah, I was always around the fire service. Now the engineering side, I really didn't pick up on until many years later. I really didn't even know that this field and industry really existed to the extent that it does. So yeah, that was my overall start in this field.
That's interesting because my grandfather was a firefighter, and I think I always had some interest because of that. But he's a firefighter, so it's interesting. That's a common theme with fire protection professionals is they get a taste of the industry or what fire protection is, and then you either do go into design or you just stick to firefighting or plan review, or there's so many avenues. So I always find it interesting to talk about people's origins and how they got into it. So yeah, so you see, you said it took you a while to get into the design sort of mindset or think about design as a career. I find it interesting. I think of professionals as, there's I almost separate the two, firefighters and like designers, in my head, because I just think there's such a different mentality in between the physical act of fighting a fire and then like the very office space, removed from the task design process, which is all, books and computer programs, and most engineering designers don't ever see, a real structure fire, even though they might spend their whole life designing for one, so I guess my question is, do you think that firefighting gives you a unique perspective on, the engineering design process? And yeah, what are your thoughts on that?
Yeah, for sure. I think it does. I think it's a huge benefit, especially in my career development on both sides. Now, I'm not saying you have to be involved in one or the other to be good in the other profession, but for sure, it's opened my eyes. Several specifics are working within the fire department, like you said, responding to structure fires, responding to these buildings, seeing how these systems integrate together and work, and actually provide life safety and fire protection under real scenarios has been an eye opener, and it's assisted me in the engineering side. Even as simple tasks such as locating the FDC, fire department connection for okay, we're doing the sprinkler and standpipe layout for this building. We're working with the civil engineer. Where's the best place for the FDC? Where's it going to look good, not get in the way, but also be functional for the fire department, and work with our hydraulic calcs. And that's a very small part of design, but even as simple as that has a huge impact to the fire department. There's buildings we respond to, and I'll hear other firefighters say, why would they put the FDC here? This makes no sense. How are we going to get to it? Or it's going to be so difficult for us to have fire department access here and stretch 200 feet of line over there to hit the connection. So simple things like that. And then the more technical, more advanced from, which is one of my specialties, smoke control systems. The fire department historically is scared of those more technical and active systems. So there's requirements in the code such as the firefighter smoke control panel that of course the building code requires these for fire departments, but the training and background to teach them and know how to operate them or even what they do and what they're there for really is lagging behind in my eyes. So being able to be in both positions, I could both provide training and insight to specifically the guys I work with day to day at the fire department.
I think that people like you who are, more knowledgeable in the engineering systems, but also, in the weeds with the actual firefighting are needed. I really liked what you said about the functional aspects of, design. I think that people who only know, 3D modeling or CAD or BIM, and then they go to lay out a system and they do something like you said, place the FDC in a location that's going to be a nightmare to get to during a fire. Or another thing I wanted to ask is like, there has to be, that's just one example. There has to be a ton of examples like that. Like I'm thinking about, clearance in a fire protection room is always a struggle because, there's always limited space and fire protection is usually, one of the afterthoughts for a building, thinking about how you're going to get into a room and, with turnout gear, what does that look like, and providing clearance and, where you place these things. That seems like it would also be a big deal. Yeah, I don't know. I just wanted to circle back on that topic because I think that that's really valuable.
No, 100%. Another example, like referencing in regards to the space that the fire department will take to operate, two things come to mind. High-rise buildings where we're going to operate, and when I say we, in reference to the fire department, off the standpipe system, there's it's gone back and forth in the codes and as well as local jurisdictions as to whether those host connections are on intermediate landings or on the main landings, and that actually has a huge impact on fire department operations. For instance, my department that I still operate in, we really lean towards the intermediate landings because it opens up some space on the main landing to operate and have people egress in and off that floor. So, certain aspects such as that, again, with the high rise route, the fire command center, a lot of times when we were consulting with architects, they're like, well, is the size of this really required to be that large? Why does it have to be so big? I could use that space for other reasons. And again, if you don't have the fire department knowledge, you could probably say, yeah, I would think just one or two guys need to be in there. They hang out and they talk on the headsets and can communicate to the guys and see what the status of the fire alarm system is and the sprinkler system. But in reality, you're probably going to have a whole crew in there initially going there to get some information about the fire event, look at the panel, get a game plan together. In high-rise buildings, fire department operations really slow down. It's not like we're pulling up to a single-family house fire and we go rolling in there and put the fire out as quick as possible. Obviously, there's a lot more risk in high rises. The operations are slowed down and very detailed and laid out so that everyone operates safely.
High rises seems to be, significantly more complex in every regard. I'm sure that's why building owners try to stay away from it as much as they can if they can. It's cool to hear things like that, and I wouldn't know that just from when I talk to architects and they're designing a fire command center for a high rise building. They're just trying to hit the minimum square footage that's required in the fire code or the building code. They're not, they're not going through all the functional aspects of, in the event of a fire, what does the operation of this room or what does the programming of this room need to be? So I think that as a fire protection professional, people need to be more aware of these kind of things, so that's really interesting. I like that. Um, so another thing that you spoke about earlier that I thought was great was your talk about how, you know, in general, sometimes that firefighters can be averse to these more technical systems like the smoke control systems, or, you get other more complex systems and it can be a problem, or just like the knowledge base for those things can be a problem. Yeah, I don't know how I wanted to shape my question around that, but that's something in my experience, from talking with firefighters before, unless people have, specific training courses on more elaborate systems. Sure, your run of the mill wet pipe system, but I mean, as soon as you get into these more, maybe smoke control, or maybe you got a pre-action system, or you get into stuff that's a little bit more in the weeds. I find that not just for firefighters, but for fire protection designers or engineers in general, sometimes that knowledge on these systems can be very lacking. So I liked that point that you made about that, and that people need more education and more resources for that sort of thing. So yeah, I just wanted to circle back and touch on that. So you are a part of a company now that specializes in performance-based design, and I noticed that when we start talking, you are readily available with great information about high rise, and this, which seems like a common place where performance-based design would be involved. What is performance-based design, and is what is that an alternative to?
Sure. So the main basis of performance-based design is to achieve or exceed the intent of the code, of the building code and fire code. So, of course, our fire code set up prescriptive requirements such as, you need to provide a wet pipe sprinkler system to this area, this hazard classification. That's very baseline. Now, again, more complicated things going into sort of the smoke control or tenability systems where the code may be a little bit more performance written, not really performance based design, but it's written a performance written narrative in which you have to provide a smoke control system that maintains a smoke layer 6 feet above occupant's walkable height. So, that's section 909 of the building code specific to an atrium, for example. So a performance-based approach is really when the design team, the architectural team is limited and they cannot meet the intent of the code word for word. So there may be an existing condition that's present, or something very unique that just doesn't fit within the code structure, the networks of these codes, when they're written versus where we are in design now. Obviously, the buildings we see going up, the modern built environment, architects and design teams and developers are pushing their concepts to the limit, right? And a lot of things just don't fit in to the code. So as a fire protection engineer, we have the capabilities, the tools, and the resources to evaluate these conditions and say, yes, this meets the intent for fire, excuse me, fire and life safety for this specific building. So performance-based design isn't a blanket statement. It's not that, oh, for every building we could provide X and be okay. It's looking at a specific building, a specific project and concern, and evaluating it holistically against fire and life safety conditions. So, for instance, if an architect wants to do something very specific that is a little bit different from the prescriptive nature of the code, we really have to evaluate everything holistically. We have to look at egress, we have to look at fire protection, we have to look at smoke control systems. We have to consider everything cohesively in order to determine if that's an appropriate solution.
That's a great point about fire protection in general is a holistic approach. I think that escapes a lot of people, and I mean, even when I worked as a fire suppression designer, and just knew that part of the business. I didn't realize that either. I think only as you get into the role of the engineer and you start to approach the building as an entire system, do you realize that, you know, there may be a section in the code that says whether you need a sprinkler system or not, but, what else does that trigger? That affects egress, that affects building height, that affects, like your allowable area for certain occupancies. So I like that point about approaching performance based design as a holistic approach to a design process for fire protection engineering. And that's really interesting. I like that. Yeah, performance based design is an alternative to prescriptive design, which is the conventional method for design. I think it's very interesting, people designing for the new built environment. And I just took a trip to Vegas recently. And yeah, I never thought about performance based design more than when I was walking through these buildings that are, several magnitudes larger than anything I've ever walked in before. And, that I just had the thought that there's no way that these buildings fit into the normal footprint of the building code or the fire code. There's just no way. This is not what people were thinking of when they just started developing these standards. So I think that's really interesting. You're talking about, the future of the built environment and how performance-based design is only going to be more applicable just due to the fact that building owners and architects are, by their very nature, going to be pushing the limits of uh, of that sort of thing. So I know you touched on some of the types of systems for that could be considered for performance-based design. What would you say is the most common type of system that is used for performance-based design, or is it always approached as holistically, like you said before, and where if you're thinking of performance-based design, the whole building is to be considered?
Yeah, so it typically is always that holistic approach, but specific to a system, I would have to say smoke control systems in particular. Now, of course, again, with the verbiage of the building codes, it typically says you need to provide a smoke layer X feet above the highest walkable floor. So that, in its sense, it's kind of a combination of prescriptive and a performance requirement. They're telling you what you have to do. They're not telling you what that capacity needs to be for that system. So a lot of I kind of group performance-based design and then the actual fire modeling together. Again, even though when we do the fire modeling side for a smoke control system, it could potentially be directly allowable by the code. But smoke control systems themselves are where we utilize some of the tools and approaches of performance-based design, such as the computational fire modeling, fire dynamic simulator, FDS, which is the most common utilized one in the States, is what you're going to see. And those are the analysis and approaches. I'm not sure if yourself are familiar with it, but you'll see them floating around the internet and some articles about smoke control systems or fire modeling, looking at expected temperatures in a compartment or smoke movement throughout a space. So those are typically where you'll see the highest utilization rate performance-based design. Other aspects are, and the more common approaches are looking at performance of non-rated structural steel. So perhaps the most common and textbook approach would be like an elevated walking platform in a gymnasium. Again, based on the prescriptiveness of the code, most likely you would need to sprinkler protect under that balcony, as well as have the structure itself be have spray applied fireproofing to match the construction type for the building. But when you consider the overall hazard in those spaces and the potential for a fire event, a common approach utilized in a lot of those in universities and other gymnasiums is to do a fire modeling analysis based on, again, expected fuel load in that space, which could vary. You could have a small incipient fire, but you could have a large expo, going on in that space. So we could look at those design fires and look at the thermal impact, the thermal insult to that elevated platform, and determine would any additional fireproofing be beneficial? Should the sprinkler protection remain under it? Most likely, yes. Or would the ceiling protected only sprinkler system be appropriate? So those are a couple, of the more common ones that jump to the top of my head off the bat.
That's good stuff. Smoke control would be the one that would come to my mind first, since it seems like atria are very tricky and can kick you over into where a situation where performance-based design would be beneficial very quickly. But I wouldn't think of structural rating for steel columns as something that would be performance-based design. So that's really interesting to hear you say that. Yeah, just to talk a little bit, I liked when you started talking about the different kind of programs and modeling software. So I heard you talk about FDS and Pathfinder. Was that the one that you were speaking of?
Right. So yeah, Pathfinder is one of the egress tools. So there's numerous validated and verified models that we could utilize. Me myself and my firm, we lean towards FDS and Pathfinder. So FDS would evaluate the actual fire conditions and the smoke movement, and then if we need to, we would pair that with the egress analysis, Pathfinder. So again, keeping on that smoke control route when we're looking at an atrium. Again, keeping that smoke layer 6 feet above the highest walkable floor. Well, in a performance-based approach, we're allowed to descend that right from the sixth floor to the fifth floor to the fourth floor, as long as we're showing that tenable conditions are provided long enough for egressing occupants. So, say you have a six-story atrium, but you only have 500 square feet of walkable space on that highest floor, and we have an occupant load of X people, as long as we show that X people can safely egress with a lot of conservativeness and safety factors, pre-movement time, time to detection, time to notification, and a delay in their movement speed. As long as we show those people get off that floor, why can't we let the smoke layer descend past it? So now instead of a 300,000 CFM exhaust, we could start decreasing it based on how far down the atrium, the elevation of that smoke layer we could descend. So again, that's the perfect example. And in the prescriptiveness of the code, word for word, you have to maintain that smoke layer for a minimum 20 minutes or 1.5 times the egress time, whichever is greater. So if we had an egress time of 30 minutes, we would need to maintain that smoke layer above the level 6 for 30 minutes. Or if we're able to show that everyone gets off of that floor and the subsequent floors in 5 minutes with a ton of safety factors, so we're very comfortable with the approach, we may be able to reduce that capacity by 50%, if not more.
That's a big deal because, working with HVAC engineers, those systems are very costly, and those units usually for those HVAC systems are large. And so, man, I bet that people are interested in somebody who can provide solutions like that, who can, downsize units and, provide effective life safety measures. So it sounds like an all around win to me as far as providing the intent of the code, which is the code is there for life safety. If you're meeting that, then I see no reason why that we can't be more specific. Other engineering disciplines are more specific in their application of their equipment and systems. So I feel like that is the future of the fire protection industry is more prescriptive methods in order to be design more to a specific set of parameters instead of the very broad set of code that we are designing it now. Yeah. So my other thought on FDS and Pathfinder is how hard are these programs? It seems like FDS is seems like a very difficult program to be able to set up and define all these parameters. How hard are these programs to learn and to use? They seem like they have a pretty high barrier to entry or learning curve.
Right, right. No, that's a really interesting question, and I'm probably going to surprise you with my response. And my response is that they're relatively easy, in the sense that there's new tools that allow it to be easy, in terms of setting up a model. So there's graphical interfaces available now. One again, Pathfinder is a specific graphical interface made by Thunderhead Engineering. Thunderhead Engineering is a software development company for a wide range of engineering disciplines, but they definitely are specific to fire protection. They have a graphical interface called PyroSim. PyroSim allows you to build geometry, build spaces, import data to construct your model and run FDS as the actual simulation software in the background.
Hmm.
That being said, You could go ahead and you could download PyroSim for they do free trials, and you could play around with it. You could build walls, you could build a room, you could put a burner in there, and you could hit run. The difficult portion comes into understanding how FDS works,
Yeah.
its limitations, how it's verified and validated. What I've seen, it's both good and bad. There's a lot of people getting into fire and ERS modeling in the field over the past 5 to 10 years because of these tools. Prior to these
Mm.
tools, what you're referencing is exactly right, and the background behind it is still correct. The input code for FDS model is basically a text file, and it could be
Yeah.
tens of thousands of lines or hundreds of thousands of lines of input
Wow.
code. So what PyroSim does is it basically, you're drawing walls just like you would in CAD. You're making it 3-dimensional, and it's making that code for you in terms of the geometry. So,
Mm.
I feel very comfortable that most people within a couple of days could build a simple room. Again, the background behind it of actually how do you define the fire characteristics, how you define your fuel properties, how large of a fire you're modeling, and all the parameters that go into it, your atmospheric pressure, your ambient temperature conditions, your boundary conditions, how you're defining your obstructions. There's different ways we quantify them. Are we going to use the actual material properties, such as drywall or steel, insulation within that cavity, or are we going to assume they're adiabatic or inert surfaces where no heat transfer or limited heat transfer is taking place for the model? So there's a lot of technical aspects, which is where um, the education and experience comes into play. So overall, again, someone could easily download these programs and start playing around with it and messing with them. But the background and the understanding of the software is the important part, and where you could get into trouble.
That's really great info. It sounds like, and the only parallel that I could draw to that is, you know, when a designer goes to design a sprinkler system and they want to do a hydraulic model, it doesn't take that long to learn how to put the nodes in the program and input the data. But I like what you said about it's all these other factors and parameters that come with time and experience that you're inputting that could trip you up. And so yeah, I like that what you said, that it's not hard in the thought of the formal aspect of operating the program. The difficult part is where you have to have the engineering knowledge and background to know when to use what parameters and when to use what inputs. So I guess that makes sense intuitively. That makes sense that it's not as technology is just keeps getting easier and easier to use. So as long as you know what kind of inputs you need, that it's not extremely difficult. Yeah, I guess I just have seen those text files for FDS and just thinking like, so I have to learn a coding language to be able to do fluid dynamics simulations. I'm like, wow, I would love to get in and start tinkering around with FDS. And I've seen that there's versions of it that you can get for free, or there's no huge um, licensing cost for these. So I've had a lot of thought about, yeah, I'd like to get a hold of one of these and mess around, but I'm like, this looks heavy. I don't know if I can just pick this up and start to learn about it. But yeah, I really find that interesting. In the vein of talking about performance based design, how much does the authority having jurisdiction have to do with performance based design being an option?
Sure. Yeah, the AHJ is really one of the big, I'll use the phrase elephant in the room in regards to performance based design. There's certain jurisdictions that are on board. They've utilized it in the past. They've seen the impact that it has on the projects, and the benefit that it provides while maintaining or exceeding life safety. So certain AHJs are educated on it. They're all about it. Other ones, more the old school mindset of, no, this is the code, this is what we need to do, I want to see this done. It's really an education thing. So a big part of myself and my firm's task right now is education, getting out to cities and AHJs, regardless, in addition to architectural firms and engineering firms to display, this option, but the actual AHJs themselves who are going to be seeing these come across their desk to say, hey, our current code systems do allow for this. Historically, it's been a little lacking behind, specifically other countries that have utilized performance-based design almost entirely in their code system. So the United States is a little bit behind, but there is room for it as an alternate means and methods within our code system. So providing that background and that education, and to essentially make them feel comfortable with how we go about these approaches. All the thought process and justifications that go into these are what they want to see and understand. So, for instance, we like to, if a design team is implementing a performance based design, we like to engage the AHJ as early as possible. You don't want to spend all the time and effort and money on this analysis for it to get to the city and they say, no, we never said we were entertaining this approach. We don't agree with this approach. We're not accepting it. So, regardless if I've gotten in front of them to do some education, independent of a project, if a project does come up in a municipality, one of the very first steps is I reach out to them. I say, hey, this is what we're proposing to do. One, are you going to entertain it? If not, let me have a discussion with you, and we'll have a good conversation on where this approach applies and how it's going to be performed. The next step after that is to actually give them a formal document. So, for example, for specific to a fire modeling analysis or egress analysis, we call it the design brief. And the design brief goes over, again, the overall intent, why we're doing this analysis, and all the justifications. So our parameters, and as we discussed earlier, our inputs that we're going to use for the model. So again, if we're doing an atrium, we're going to lay out all our design fire scenarios. We're going to say we're examining this fire because of this reason. We're also looking at a fire over here because of this reason. And oh yeah, we're going to do a fire at this exit location to omit an exit location from this scenario to make it more demanding. And at that point, we want to get their buy-in, and they say, okay, yeah, we're good with this approach, and then we'll go ahead and do the analysis. There's still some AHJs, which again, and they're not expected to, right? The AHJ isn't expected to know and understand everything in the engineering and construction industry. They may not be comfortable with fire modeling. They may not have experience with it. So they would have the right within their building code structure to request a third-party reviewer, which really is the common approach. And the Society of Fire Protection Engineers has a document for guidelines on performance-based design, and they explicitly state that you should have a third-party review done on any performance-based approach. So that is another resource that the AHJ has to understand and approve a design.
I think that approaching an AHJ and having dialogue with authority having jurisdiction and talking through the process of a design solution for any project is one of the most difficult things that we do as a fire protection engineer. And it sounds like with performance-based design, it's something that is not only unavoidable, but the process can't even go through its full cycle without the buy-in and the intimate working with the authorities. So that's really interesting. I think that's great to know about. Yeah, I just think that it's one of the most difficult things to get buy-in on your design, even when your design is conventional or maybe just outside what they're used to seeing. So I can imagine that people would apprehension or just like not used to seeing these types of models. So that's really interesting.
100%. Yep.
So the process it sounds like you have the process down for speaking with the authorities having jurisdiction and just fleshing out this design process. You went through the steps, establish a dialogue with the AHJ, see if they'll even entertain the idea. If they won't, schedule a meeting with them to have a conversation about what performance-based design is and what their thoughts on it are, giving them the design brief. And sounds like the design brief kind of goes back to for smoke control where the code required design fires are and what those parameters are. And then I wouldn't have thought about it. Makes a lot of sense for an AHA to have a third party reviewer. I mean, even as somebody who's working on being a fire protection engineer, I would know how to review a smoke control or a FDS simulation. So I can't imagine somebody who was a AHJ to have all the, especially one with not very much experience with performance-based design, to have all the resources they needed to review a simulation like that. So this is all very interesting stuff. Do you have a specific example of a project that you've done in your career that was interesting that involved performance-based design? I'm sure you do.
Yeah, for sure. Numerous examples. One of my most prominent ones was a major arena which was employing a smoke control system due to smoke protected seating. So they were reducing the aisle widths a little bit, which triggered the smoke protected seating provisions of the building code. So again, the mechanical engineering team would have been able to do hand calculations, and they did perform those. And the exhaust capacity for that arena bowl was 1.2 million CFM of exhaust. Now, of
Wow.
course, when you have an exhaust that high, like you referenced the demand on the mechanical systems, that has huge architectural impact as well, because when you're exhausting that smoke, you need to make it up somehow, right? Or almost entirely make it up. Typically, at least 80% of it needs to be coming somewhere, and they're remaining from building leakage. So if you don't want large shafts, more shafts going through your building and more mechanical systems, you need to provide natural makeup air, either through doors on openers or large roll-up doors or louvered areas to the exterior. So when the design team was first looking at that, they're like, "Oh my gosh, like this is ridiculous. How are we going to achieve this? This completely messes up our architectural desire if we have thousands of square feet of makeup air." So we proposed the fire modeling approach, doing a fire modeling and paired with an egress analysis. And again, in this specific example, we were able to reduce it by about 50%. And the final exhaust capacity justified in the final rational analysis was 600,000 CFM of exhaust.
That's a big win for everybody because not only are you affecting architecture, you're affecting structural because the units are bigger, you're affecting electrical because units that are that big need more power to feed them, and that might kick up your feeder size, or it affects all the disciplines to be able to provide these life safety solutions. So that's great. It's awesome that you're adding value to projects in that regard. And I think that that's really neat.
Absolutely. Thanks.
Yeah, I know that we talked about a little bit before how, it took you a while to get into the mindset of, uh, design or engineering. As a young designer slash engineer myself, I've had struggles with getting into the field and learning, and fire protection is feels like such a very young discipline, and there still aren't a lot of amazing resources or materials. But can you tell me about a time where you maybe, or what was difficult for you when you first started out in engineering, or can you remember any hurdles like getting into the design process?
I would say for me personally, it's the communication aspect. So, when you're thrown into, like you said, in your early in your career, you're doing your first or your second design project. Again, maybe it's a sprinkler system or a fire alarm system. A relatively, you know, major part of our field and what a fire protection engineer can provide. Really, communication with the design team, from the architect to the MEP team to the project stakeholders. Learning how to communicate, explain what you're doing, why you're doing it, and having that open dialogue. I feel like sometimes when you're early in your career, you may not feel like it's your place to speak up or ask certain questions, such as, hey, even simple ones, where are we putting the fire alarm panel? These are simple questions that you need to coordinate with the design team. And yeah, when I was a young engineer, again, I've been in this for about 10 years now, so I think it was harder for me to do that. And what I've learned over the years, and to the point where I'm at now, is like you're saying, because fire protection is relatively new. Maybe other professions were handling it previously, opposed to a fire protection engineer specifically. Is we need to be vocal. In kickoff meetings, we have to say, "Hey, you need to give me X for the fire command center. Hey, you guys, I haven't done the analysis yet, but I would expect somewhere around 100 to 200,000 CFM of exhaust for this atrium." Or again, a high-rise building with stairwell pressurization. They may not know that early in the design that's required by the code. So have that communication, not being afraid to speak up. You are the design professional in your industry, and it's your responsibility to make sure people are on board as early as possible. Likewise, my second, I guess, difficulty that I learned is when you make mistakes. We're all human, right? No one's expected to be perfect. Well, they may want you to be perfect, but you're going to make little mistakes. You may notice a small error. Maybe you used the wrong C factor in your hydraulic calc, and it didn't throw off your go no go on the need for a fire pump or your main sizing. But that was a small mistake that wasn't represented correctly. And again, ethically, you have the responsibility to bring that up and say, hey, you know what? Those calculations I sent over on Friday were incorrect. I had a brain fart, and I realized over the weekend that I made a mistake. And please see the attached update. Rather than hiding it and maybe trying to slip it in the next submission where it could have a larger impact. Both really tie into communication, but the overall communication with your intent of your role and your scope in the project, as well as making mistakes or noticing someone else make some mistakes and having that communication open.
Those are great points. You know, starting out, I think that you think that fire protection is going to be the most difficult part of your job. It turns out that at the end of the day, fire protection is the easier part of your job, and that actually coordinating with other disciplines and working as a team and being involved with getting stakeholders in a project to work together and communicate, that's the real difficult part. So I like what you said about coordination and communication and just being involved with the project team. I think that's all great info. Yeah, I definitely could feel that too, knowing in a coordination meeting, oh, we need you to move this diffuser because we have to be in this spacing, or, oh, we need our panel here, or we need X amount of space for our fire pump, or, all these things require you to speak up and be the design professional in the situation. So yeah, I definitely see what you're saying about that, and I feel that struggle too, even still now. So yeah, that's awesome. And with mistakes and calculations and communicating and being ethical, I think that that's a great message. I think that people can learn from being straightforward and honest about hydraulic calculations, or just knowing that it's a life safety system, and you have to for any system you want to do the ethical thing. But yeah, especially in fire protection, where we have such an onus to be as accurate as possible.
Absolutely. Yep.
What do you see as do you see any emerging trends in our industry, or with performance based designs, or is there anything that you see as developing?
Really, just the overall approach. So I'm involved with several task groups and committees as part of societies that are really, again, which has my direct interest in educating the AHJs, but really working on driving and developing the use of performance-based design. So for me, that's the trend that sticks out because I'm so intimate with it and is my go-to work type and the work type I enjoy doing the most. Of course, we are in the design side too, but that performance-based approach, again, historically in the U.S., it's lagged behind some other areas, specifically geographic areas. Australia, New Zealand. These are countries that have leaned on performance-based design for many years, and their code systems are pretty much entirely written to support it. Um, what's interesting, this one committee I'm on, this one task group is comprised of engineers from essentially all over the world. So we have engineers here in the States, New Zealand, Australia, Europe that are part of this group, and hearing how everyone utilizes it a little bit different, the different requirements, the stringency of how they do performance-based design, it varies geographically. And yeah, to be honest, in the States, we're probably a little bit behind, but because we're a part of this process and we're working with them, we're coherently and everyone comprehensively developing essentially a standard. And it's the goal is to get it approved as actual standard where people could reference across the globe. Hey, this is how you do performance-based design. This is the overall approach that's approved that everyone should be following. So trend-wise, yeah, I'm going to be a little biased towards that performance-based route, but that's where I see us going, especially here in the States.
That's great stuff. Of course, you are familiar with what you are involved with on a day-to-day basis. That only makes sense. That's interesting. I meant to bring that point up earlier when you had talked about internationally where the U.S. stands with performance-based design, and you mentioned a couple countries, and that's what I meant to ask earlier is, what other countries are more forward with performance-based design, or over in Europe, is it more common? It seems like I just spoke with somebody recently who does research in sort of performance-based design slash egress design, and he's in New Zealand. So that's funny that you mentioned New Zealand. But yeah. So what other countries are really progressive in as far as performance-based design?
Yeah, those are really the big ones. Sweden, um, Australia, New Zealand, um, Canada is probably similar to us. They're dabbling with it, and it's becoming more mainstream. Japan has done a good amount of research and development of it. So really, I think you'll find it being utilized, in some extent across um, many countries. And I'm not in no way saying the United States is behind these countries. It's just, we have the tools and the approaches available to us. It's just not as common in our day to day design process.
It's not like we're behind in the regard that, we couldn't do it. It's just not as ingrained in our codes and standards, is kind of what you're referring to.
Correct.
Um, so I see that I was looking at your LinkedIn and I see that you're a PE. Can you talk a little bit about what it is to be a PE and how you got your PE?
Yeah, sure. So now, I do have to have a disclaimer. They have been changing some of the requirements specifically over the past couple of years, but when I was pursuing it, and still to this day, the first thing is an ABET accredited engineering degree. Without that ABET accredited engineering degree, you have to show pretty extensive years of service in your field in order to sit for the PE exam. So starting back from my education, I went to the University of Maryland and got my Bachelor of Science in Fire Protection Engineering. So a plug for Maryland. They're one of the only undergraduate programs in fire protection engineering that is ABET accredited. And we talked to a lot of people in the architectural engineering field. They didn't even know fire protection is a
Yeah.
degree, but it is a recognized and accredited degree program. Your major programs are Maryland, Oklahoma State, of course, Worcester Polytech has a master's program. EKU, University of New Haven has fire science. I don't believe they're accredited in engineering, but they're more the arson and investigation side. So these schools are available. Here in North Carolina, you have UNC Charlotte. They have a fire science technology program, actually fire engineering technology. So these programs are out there. So yeah, I got my Bachelor of Science from Maryland. I then transitioned both into the fire service. I became a career firefighter and also was working as a consulting engineer to start gaining my experience. So once you have your degree, again, this is where the change happened. At the time in North Carolina, you had to show 4 years of progressive engineering experience before sitting for the exam. So what that means is you're working under a licensed engineer and you're going through the development of a young engineer. So from people giving you simple tasks, from design work or code consulting, working your way through the code system to over those 4 years, the engineering board wants to see you progress. So you may start some project management. You may be bringing in your own clients and projects. And essentially, they most likely want to see you taking a project from conception to delivery. So obtaining the client, writing a proposal, doing most of the work besides the review, and then submitting that as the final deliverable. So that's what they want to see as progressive engineering experience. So once I hit that 4 year mark, I was then eligible to sit for the exam, and what that entailed was studying for about 5 or 6 months pretty diligently to make sure I passed on the first time. I will say Maryland definitely prepared me for that exam, but really a lot of the stuff you will learn in your actual career. So actually being in the field, doing the work is where you pick up a lot of that stuff. And what's good about fire protection is, it wasn't like studying for dynamics exam in college. You enjoy getting into the codes and the fire protection handbook from the SFP and the NFPA, going through those and picking up things, being like, oh, that's interesting. I forgot about that, or I never heard about this approach or this calculation. So it was actually fun studying. It's crazy to say, but studying every night, working through problems over that time period, and passing the exam. Um, Today, so that was 3 or 4 years ago. Today, I believe you could actually sit for your PE exam whenever you feel ready. So as soon as you get your degree, it's accredited. I believe now you're approved to take the exam, but they won't license you. They won't give you that certificate until you show that experience. I believe that's how most engineering boards are handling that now. And fire protection, I think, was one of the last disciplines, but they just are going to computer based this year in 2020. So it's going to be a computer based exam, which me personally, I don't know how I would have performed on that, whether it been better or worse, but I was on the old paper system, the 8 hour exam. And I guess I missed a key step, which would be your FE, your fundamentals of engineering, is the first test you need to take before being eligible for your PE. So your fundamentals of engineering is more of a overview of the overall engineering curriculum. So although me, myself, and others studied specifically fire protection, it was pretty much a mechanical engineering path where, of course, you're taking your statics, dynamics, chemistry, physics 1, physics 2, differential equations, all those fun classes that some of them I had to take twice. And that's what your fundamentals of engineering test is. Once you pass that, there wasn't a time you could take your FE, in the spring, and then take your PE that fall as long as you met your years of experience. But those were the two requirements that you had, the two tests that you had to pass.
I lucked out recently. I got to take the last paper exam for the PE, and I passed my PE this last October. So I was pretty excited that I don't have to
Very good.
study for it again and try to learn what they changed in the between the computer based and the paper based exams. I imagine it would be harder to take the computer based because you're not allowed to bring in any references. For the paper base, everybody brings in crates full of books that they've highlighted and tabbed, and
That's right.
so I imagine that's going to be a much different experience for people taking the computer-based exam.
That's right.
Yeah, so I think it's interesting. Yeah, about the decoupled. They've in some states they've decoupled the experience requirement from the being able to take the PE. So yeah, like in Oklahoma, they have decoupled the. You don't have to have your 4 or 6 years of experience in order to take the PE. So even though I still need, 4 months, 3 months to get the experience all needed for the PE, I was still able to take the PE. So that's really nice. Yeah, I think that there's like 15 to 20 states that have that experience decoupling now. So that's pretty neat. Yeah, it's
Okay.
different. There's so many differences at each state board. I spent a lot of time researching state boards for what requirements I meet, and being I know that Maryland is a ABET accredited engineering degree, which is different than OK State or Oklahoma State University is a ABET accredited engineering technology degree, which some states see in different lights. Um, they credit you for more experience for the engineering degree over the technology degree. So, yeah, it's interesting. I only knew of, even being in a fire protection program, I only really knew of Maryland's program and Oklahoma State's program. And since I've been out of school, I've looked at, you named a couple of master's degree programs like the Cal Polytech and the WPI and some of those other schools. So yeah, it's very tight knit for education and for everything else, really, for fire protection. So Dave, thank you so much for coming on the podcast. I appreciate your time and for sharing your great information about performance-based design and your career in fire protection. I just want to thank you and say I really enjoyed having you.
Yeah, absolutely. I enjoyed it as well, and thanks for the opportunity to share my experience and insight. And yeah, I look forward to the future of the career and the success of your podcast as well. So I'm excited for the other episodes.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.